Back at it again today, and today we will be stressing on the topic functions, or the concepts of functions. We have 3 or 4 aspects of functions that we want to touch on. This tutorial video will be touching on each of those aspects. Now the first part of function that questions could come based on is that of substitution of a number into a function. When it is that we have substituted a number into a function, let's say we are given 2 functions. We are given f of x is equal to the function 2x minus 3. And we have g of x is equal to the function 3x plus 4 all over 5. So we have 2 functions. We have the f of x function and we have the g of x function. And in the first case, example 1, let's say they want us to find f of 3. To find out f of 3, we are taking the f of x function. And why we are using the f of x function? Because this letter tells us which function you will be using. So if it is that you have f of a number, the letter tells us which function you will be doing the substitution into. So taking the f of x function, f of x is equal to 2x minus 3. We take the function and we replace the variable with the number in the bracket. So we're replacing the variable x with the number in brackets, so we replace it with 3. Minus 3, so it's read as 2 open brackets 3 minus 3. 2 by 3 is 6. 6 minus 3, we get 3. So basically what we did here, the function f of x is equal to 2x minus 3. We replace the x in that function with the number in brackets. Let's say they give us our next example. Example 2, they want us to find g of, let's say, 0. To find g of 0, what we do is that we take the g of x function. The letter tells us again which function you will be using. So taking the g of x function, g of x is equal to 3x plus 4 all over 5. And we are replacing the x in that function with the number in brackets. So we get 3 open brackets 0. That is g of 0. We're replacing the x with 0. So we get 3 open brackets 0. I like to work step by step. Plus 4 all over 5. When simplified, bracket means to multiply. So 3 by 0, anything by 0 is 0. Plus 4 all over 5. So 0 plus 4, we get 4 over 5, which can be left as a fraction, or some persons like to write it as a decimal. 4 over 5, when placed in the calculator, I get 0.8. So that is one part that you all can be tested on, substituting a number or a constant into a function. The function, the number is just replaced. So we are replacing the number into the variable when it is that we are doing questions on this. So the number that we have in brackets, we are taking that number and substituting it into the expression for whatever the variable is. The next part is called part 2. This is called composite functions. Now composite functions are next way that we refer to this as, it is called a function of a function. And this is how the question could come. Let's say this is example 3. A function of a function, let's say they had asked us to find probably the function g of f of x. Now the steps for this are simple. These are the steps for it. You're working in a systematic order. So if you want to find g of f of x, you see the first letter that we are seeing coming from the left going towards the right. That first letter, we are writing on the function for that first letter. The function for the first letter g is 3x plus 4 all over 5. So when it is that you write out that function, the next function, we're taking that function and we're replacing the variable with that function. So anywhere you see x, you're taking out that x and we're replacing the x with the next function. So we're taking out that x and we're replacing it with the f of x function. F of x is 2x minus 3. So if the x is replaced with 2x minus 3, this is how we will look. 3 open brackets 2x minus 3, because anywhere we see x, we will then replace it with the next function, which is 2x minus 3. And if you were to tidy things up, this is how it will look. It will be 3 open brackets 2x minus 3 plus 4 all over 5. And we simplify this. Bracket means to simplify. So we get 3 by 2x, 6x. 3 by minus 3, we get minus 9. Plus 4 all over 5. When simplified further, we get 6x minus 9 plus 4. Minus 9 plus 4 is minus 5. So we get 6x minus 5 all over 5. So this is what g of f of x is. This is called a composite function. Now this is one way that this question can be asked. And next way that they can ask this question, let's use an example 4. Let's say that asks us to find g of f of 2. To find g of f of 2, the first thing we need to do, we need to find g of f of x. And when it is that you find g of f of x, then you go and you replace the x with 2. So then we find g of f of 2. So that's the first method. Find g of f of x and then replace the x in that expression with 2, with the number in the bracket. So that's the first method. Let's work it and see. We already know that g of f of x, when it is that we worked it initially in the last part, we got g of f of x being 6x minus 5 all over 5. That is what g of f of x is. And we are replacing now the x with the 2. So if you replace the x with the 2, this becomes 6 open brackets 2 minus 5 all over 5. So we get 6 by 2. We get 12 minus 5 all over 5. And 12 minus 5, we get 7 over 5. 7 over 5 is the same. You can write it as 1 and remainder 2 over 5. So it's 1 and 2/5. Or you can write it as a decimal, which is the same as saying 1.4 if it's worked in the calculator. Right, so all this here is different ways that we can write it. This is the first method that we can work this. The next method is finding the same thing, g of f of 2. How it is that we can find that? You see the letter closest to the number. So you see the f, you work out that function first. So you work out f of 2. So finding what f of 2 is, that means that we're taking the f of x function and you're replacing it with 2. The f of x function is 2x minus 3. But the x is replaced with the number in brackets. So you get 2 open brackets 2 minus 3. 2 by 2 is 4. 4 minus 3, we get 1. So we know what f of 2 is. F of 2 is 1. So if it is that this expression is simplified, in place of writing f of 2, you replace f of 2 with 1, because that is what we got for the expression f of 2. When you work f of 2, you got 1. So you replace f of 2 with 1. And now you find out g of the 1. So to find out g of 1, you're taking the g of x function. The g of x function is 3x plus 4 all over 5. You're taking that function and you're replacing the x with 1, the number in brackets. So you get 3 open brackets 1 plus 4 all over 5. So when we reduce further, 3 by 1 is 3 plus 4 over 5. 3 plus 4 is 7 over 5, which is the same thing as we got on top here. So these are the two methods that we can use to find for the function of a number. You can either find g of f of x first and then replace the x in the expression with the number in brackets, or you can use this method where it is that we find the function of the number closest there. So we found out f of 2. And when you get the number for f of 2, you replace that number into the next function, which is the g of x function. So we replace the x in the g of x function with the number 1. And when it is that you replace that x with the number 1, we got the same answer as above, 7 over 5. So these are some questions that you can bring on functions. Our next question that you can bring on function is asking us what the inverse of a function is. So using the same examples as given, the examples were f of x and g of x as indicated above, we can find out what the inverse is for each of those functions. Now let's call this example 5. Let's say they want us to find for the inverse of f, or the inverse of this function f of x. And next way that they can write this, the inverse of f of x could be written as this. f to the power minus 1 of x. This means f inverse of x. So that is how it is that you write the inverse of a function. If they wanted us to find g inverse of x, it would have been written like this: g to the minus 1 of x. It is read as g inverse of x. When it is that you're finding for the inverse of a function, there's 3 simple steps. The steps to find the inverse of a function: step 1, you let y be equal to the function. So that is step 1, let y be equal to the function. Step 2, you interchange. So we interchange y with x. Alright, so we interchange y with x and x with y. What this means is that anywhere you see y, you put x, and anywhere you see x, you put y. That is what interchange means. And the last step, you transpose to make y the subject of the equation. Subject of the equation means that you want y alone on one side. Now these steps they're just looking a bit spooky, but when it is that you see how it is that it is applied in an example, it will all make sense. So it's just a matter of applying it and see how it is applied. It is being applied. So in the first case, let's say they want us to find f inverse of x. So finding f inverse of x, following the first step, you let y be equal to the function. So if f of x is equal to 2x minus 3, you let y be equal to that function. So you let y be equal to the function 2x minus 3. So that's the first step completed. Your second step, you interchange y with x and x with y. So anywhere you see y, you place an x. And anywhere you see x, you place a y. So that's what they mean by interchange y with x and x with y. So the second step completed. The third step now, you want to transpose to make y the subject of the equation. That means that you want y alone on one side of the equation. So making y alone on one side, first you need to get rid of this minus 3. So if you bring across minus 3 on this side, it is read as x minus 3 now becomes plus 3 is equal to 2y. And 2y is the same as saying 2 multiplied by y. The opposite or the inverse of a multiplication is division. And whatever I do on this side, you must do the same thing on this side. And to get rid of the 2, you divide, and you divide by that constant which is in front of the variable. So you get to get rid of the 2, you divide by 2 in other words. If you divide by 2 on your right hand side, you also divide by 2 on your left hand side. So what we get y, which is being left alone, is equal to x plus 3 over 2. And you see that expression, x plus 3 over 2, once as you fulfill these 3 steps, that expression represents the inverse, which is called f inverse of x. So any function, once as you follow these 3 steps, you can find out the inverse of any function that CXC throws your way. So the inverse of f, or f inverse of x, is read as x plus 3 over 2. Now a more complicated function than CXC can bring is one involving where it is that you have a variable in the numerator and a variable in the denominator. So I'll just change up g of x a bit. Let's say they give us 3x plus 4 all over 5x minus 2. Let's say this is g of x. G of x is equal to this function. And we completed f of x, so we don't really have any need to leave that on the board. We just focusing on this g of x function. So this is the more complicated questions of all of the functions that they can bring, involving a function where it is that you have a variable as the numerator in your numerator and a variable in your denominator. So we have the function g of x being equal to 3x plus 4 all over 5x minus 2. And the first thing that they can ask us to find on the same subject of finding the inverse, you can find for the inverse of any function. Let's say you want to find for the inverse of this function, this particular function. You want to find g inverse of x. Now to find g inverse of x of this function, you follow the same steps. The steps to find the inverse of this function, as illustrated before, the first step is you let y be equal to the function. So let y be equal to this function here, which is 3x plus 4 all over 5x minus 2. And the next step, so this is step 1, let me just label it, step 1. Step 2 is that you transpose, not transpose, you interchange, so transpose will be the last step. The second step, you interchange anywhere you see y, you place x. And anywhere you see x, you place a y. So you're swapping x with y and y with x. So it now becomes x is equal to 3y plus 4 all over 5y minus 2 because x is replaced with y and the y is replaced with x. So that's what they mean by interchanging. A simple word, a big word with a simple meaning. Interchange means you swap it. And then the last step, you transpose. Now when it is that you have two fraction-like terms on either side of an equal sign, x can be made into a fraction. Any whole number can be made into a fraction by placing it over 1. So we have two fraction-like terms on either side of an equal sign. What we do, in cases like this, we cross multiply. Cross multiplication means your numerator on one side is multiplied by the denominator on the next side. So you can draw x, and which direction the arrows are pointing to, that's what you'll be multiplying. So we can say x multiplied by 5y minus 2, the x is multiplied by each of these two terms. So we get x, let me just write it step by step. X open brackets 5y minus 2 is equal to 3y plus 4 multiplied by 1. Anything by 1 is itself. So 3y plus 4 by 1 is 3y plus 4. Expanding this bracket means to multiply, so x by 5y. Some students could have skipped this step and say x by 5y is 5yx. X by minus 2 is minus 2x. By just working it step by step. So get good at it first and then afterwards you can eliminate these minor steps. X by 5y, you get 5yx. So 5xy doesn't matter, the order doesn't matter. Multiplication is commutative. X by minus 2, you get minus 2x is equal to 3y plus 4. So just rewriting this on top here for to get some space. 5yx minus 2x is equal to 3y plus 4. What we do after you cross multiply, we need to group the terms that have y in it on one side and the terms that doesn't have y in it on the next side. So you see this 3y? Bring them across on this side. A plus is understood in front of the 3y. See this minus 2x? Send them across on the next side. So we are grouping the terms with the x in it on one side and the terms that doesn't have x on it on the next side. So we get 5yx plus 3y comes across becomes minus 3y is equal to 4 minus 2x comes across becomes positive 2x. So we have these two terms consisting of y, these two terms doesn't consist of y. Now remember the aim of this is to transpose to make y the subject. That means you want y alone on one side. So seeing that these two terms have y in it, what we can do is that we can factorize out the y, pull out the y. So if you pull out the y, this y comes out here, we left with 5x. This y comes out here, we left with minus 3 is equal to 4 plus 2x. And bracket means to multiply. If you want to get rid of this terms being multiplied, you divide by it. So we divide by 5x minus 3. 5x minus 3 cancels with 5x minus 3. You divide on this side by the same thing, 5x minus 3. So we are left with y alone is equal to this expression on this side. So once as these 3 steps, you follow these 3 steps, the final product will be what the inverse is. So the inverse g inverse of x will be equal to 4 plus 2x all over 5x minus 3. Now these steps here again, you let y equal to the function, you interchange x with y and y with x, cross multiply. When you cross multiply, you group all the like terms together, so all the terms consist of y on one side, terms that doesn't consist of y on the next side, factorize on y, and then you simplify. And that is how we find for the inverse of a function that has a variable in your numerator and a variable in your denominator. Once as these 3 steps are followed, it's simple to find for the inverse of anything. So the last thing under functions is that CFC can ask us to find for the values of x for which the function like this is either undefined or which the function is 0. So one question that you can ask, state the value or the values Sometimes they might end up with two values depending on if it is that your denominator and numerator is a quadratic. Say the values of x, for which part 1, so we have two parts, for which part 1, g of x, which is this function given, is 0. Anytime a function is 0, is stated as 0, place your numerator equal to 0. So I'll just summarize it for you. Place your numerator equal to 0 and solve for x. So if you want to place your numerator equal to 0, your numerator here is 3x. Your numerator is what expression you have on top here. So you put 3x plus 4 equal to 0, and you solve for x. Plus 4 comes across, so you get 3x is equal to plus 4. When it goes across, it becomes minus 4. 0 minus 4, where 0 minus 4 is the same thing as say minus 4. And then you divide by the number in front of x, so you divide by 3. So we get x is equal to minus 4 over 3. If you replace x with minus 4 over 3, that makes the whole function be equal to 0. So that's what I mean by find the value of x, for which the function is 0. It is a value when substituted into the function, makes the function be 0. And the next part, part 2, for which g of x is undefined. Undefined means that it doesn't exist. So anything you put over 0 in your calculator, you will get error 2. 2 over 0, you get error 2. 3 divided by 0, you get error 2. So anything divided by 0 is undefined, or you get an error. So anytime this function is undefined, that means that your denominator has to be equal to 0. So we place it here. Denominator, make sure I can spell this correct, denominator equals to 0, and solve for x. So doing this, you place your denominator equal to 0. Your denominator in this case is 5x minus 2. Place that equal to 0 and solve for x. Minus 2 comes across, so we get 5x is equal to 0 plus 2, because minus changes to plus. And 0 plus 2 is 2. Then you divide by the number in front of x, so we divide by 5 on both sides. So we get x is equal to 2 over 5 or 2/5, or it can be written as 0.4. So this value, when placed into this, would make the entire function be undefined, or will be equal to an error in the calculator. And these are some of the concepts that you would meet under functions. Recapping again, substitution of a number or constant into a function. The second one is composite functions, or the function of a function. The third one is the inverse of a function, and then they can ask us for certain things, where it is that they give us a function involving a variable as a numerator and a variable in your denominator, and they ask us to find the value for which that function is 0, or for which that function is undefined.